Hello again. Welcome back. Patrick McGee here in Outer Sunset, San Francisco, and really pleased to have an esteemed panel here to speak about ADAS. That's Advanced Driver Assist Systems. We're going to talk about how car companies add value in safety and performance, and we have quite a nice lineup. So stand by as I introduce four people here. So we have Blair Lacourt. He's the CEO of AEye, a LiDAR company that did a SPAC earlier this year, I think in February. Blair has a really wide background. I won't go through it all. He's been the CEO of a private airline. He spent 6 years in private equity and much else. Before COVID hit, Blair, I think you were actually supposed to be in space last year on a rocket ship with Richard Branson or developed by Richard Branson. Is that right? Oh, you're on mute, Blair. But I could hear that you mouthed yes. Okay, still on mute. But anyway, I'll see if the others can top that. I hope you're able to get to space.
Sorry about that. Yeah, we're still going. You know, we're getting close. COVID slowed us down, but didn't stop us.
That's incredible. Okay, Naveen Buddharaja, General Manager of Systems and Platform in Ansys. That's a, I believe, $30 billion market cap engineering simulation company. Navin heads the team responsible for delivering capabilities for autonomy, safety, digital twins, simulation data management, design, explorations, and cloud. As if that's not enough. Quite a business card, I guess. We also have Frank Petznick from Continental. Do we say Continental or Continental when you're in the US?
Say Continental. Continental is fine.
Okay, Continental. All right. The Executive Vice President for ADAS at Continental. Frank also has a wide background in automotive, worked at big OEMs like Volkswagen, and spent 12 years at the Hella Group, a major automotive supplier. And lastly, we've got Robert Bielby with the either extremely nice skyscraper view or a fake background, he can tell us. Senior Director at Micron Technologies, a $90 billion market cap supplier of semiconductor memory. Robert, I believe you guys have a 40% market share in automotive, 3 times that of the next competitor.
No, you are too kind. Yes, you are 200% spot on. So thank you for teeing that up. But let me You're too kind.
Okay, so an esteemed panel. All right, Frank, let's start with you, just so that we're all sort of on the same page. Can you just give me a quick definition of what ADAS is, where it comes from, sort of how it differs from, let's say, just cruise control, and tell me sort of where we are these days in terms of overall revenue and growth.
Yeah, certainly. I mean, ADAS is coming basically out of this idea of a cruise controller, but now it's developing over time with a number of sensors in the car, now fusing even the sensors together. But ADAS is a pre-state of an autonomous driving car. So it is basically helping assist the driver and is able to put more and more function in there. So it is not yet fully automated, but it is okay with a lot of assistant functions. So the market is really interesting and growing pretty fast right now. So it's basically it's more than doubling every 5 years. If you see it right now, compared to 5 years ago, maybe it's like was 5 billion euro market overall in 2015. Now we are around 9-10 billion. So we're going up to 20 and 45 billion just for the ADAS part, and not talking about autonomous mobility at top of this, and even mobility as a service and all the other services coming around.
And what specific role is Conti playing?
So what we do, we have a strong heritage in all these sensors and bringing things together, providing full stacks now, and now developing into a mobility service solution provider, which we are basically on the OEM side. We are with our customers driving the ADAS portion, but now moving with our customers and with the entire industry more and more into an autonomous autonomy market, which is by far more complex and require more computing power on the one side, the right sensors, the right input on the other side. So we are basically a provider for traditional OEMs. We are doing the truck market, but we are also moving now to mobility fleet providers and really serving as a solution provider to those guys.
And am I right that I believe every second car coming off a US dealer lot today is ADAS equipped? Does that sound roughly correct?
It's in a certain level. It depends certainly on the functionality, but you're right. Yeah, that's roughly a number. Yeah.
Right. Okay. Navin, let's move to you. Can you just tell us about what role Ansys is playing and how simulation is helping ADAS come to market more quickly than were it not for simulation?
Yeah, so I think, as you guys know, Ansys is the largest independent physics-based simulation provider. So we have always, so actually Ansys celebrated its 50th anniversary last year. So we've been around for some time and have been working with, in general, the automotive industry, along with aerospace and defense, high tech, etc. And so the automotive industry has used Ansys products for a very long time. Initially, obviously, it was things like crash testing, NVH, aerodynamics, etc. And what we are beginning to see, I think, as Frank was talking about, a much larger usage of our broader portfolio that includes things like electromagnetics, semiconductors, optics, obviously, photonics, and so on. And that is being largely, if not primarily, being driven by what's going on around both electrification as well as autonomy, right? So I think we have published some numbers over the last year or so. So if you look at the traditional simulation market, physics-based simulation market, the market that Ansys plays into, was about $7 billion, is closer to about $7 billion. And the projections are over the next 5 or so years is going to almost triple, right? Being led by the kinds of things that Frank has been talking about. So it's been a lot going on here.
Blair, you're a pretty outspoken guy, so let me see if I can try to get you heated up early morning here in San Francisco. Autonomy, full AV, L4 approach, the go big or go home approach, as I call it, really gets all the headlines. It's sort of considered the sexier thing. But I think there's this argument to be made that, while the AV approach continues to postpone, when the deployment of commercial robotaxis will take place, ADAS is sort of, increasing its penetration, it's building revenue, it's building profits, it's got this intimacy with the car makers, it's arguably saving lives on a daily, if not weekly basis, or weekly, if not daily basis. It strikes me that ADAS is the place to be. Where exactly is AI positioned? Are you just in ADAS? Are you doing AV and ADAS? And sort of where is the more lucrative market? Where are all the things actually happening?
Yeah, well, you know a little bit about my biases and my background. So, look, I would say that it, depending on how you look at the problem, you come up with a different answer. And what we think, and which I think is being, proven out, is that really thinking about autonomy as a level of autonomy is probably the wrong way to think about it. It's how you apply autonomy over a spectrum. And the spectrum may be how I apply autonomy in a closed loop where I don't have a lot of sophistication. I do the same thing over and over again. Or it may be applying it in ADAS where it's at a point of time. So for instance, on the highway, and you add a certain feature. So we look at autonomy as a spectrum, and therefore I don't think you can separate some of the R&D that's being done in the robotaxi market from what's going to happen. What I do think you can separate is the business models. This really doesn't come, in some ways, comes down to what business model can either add a new feature, so that you add value and performance, or that increases safety in a car. And if you can find a way to do that, there will be a market for either a robotaxi fully functioning in an open loop environment, or there'll be a feature that will add to a car like Super Cruise or some of the autopilot stuff that Tesla has been prototyping. So I think that the way to think about this is what level of autonomy do you need, and then what's the business model that will deliver to a customer. So we're a big believer the business model in ADAS will be delivered through tier ones who have been working with car companies for the last 50, 60 years to integrate inline technology. We think in the robotaxi market, there's an opportunity right now to play in pilots that aren't necessarily delivered in high volume. And therefore, some of the tech companies can deliver directly. So we use the same technology, the same components, the same platform. We just actually go to market differently. We go to market in ADAS using partnerships, a channel, and we go to market in mobility today, because this is what they require, with a much more hands-on, direct relationship.
So what I find myself wondering, though, is if ADAS can eventually get to the stage where it, quote unquote, unlocks the AV potential. Now, maybe that's 5, 10, 15 years away. But if that is possible, if the end game of AVs and ADAS approaches are to some extent the same, or at least the lines converge, it strikes me that ADAS is sort of the better way to get there, because it's not just cash burn, it's an actual product that improves over time.
Well, listen, I would make a strong statement, that you can't get there without ADAS. ADAS is the tip of the spear. I mean, coming from a military background, you will not drive the prices, increase the functionality fast enough without mass deployment where you have an ecosystem working on it. What I believe, our belief is that ADAS will drive up reliability and drive down costs that will enable more implementations of fully functioning open loop autonomy. So what I believe is those two curves will merge together, where that a lot of the R&D and the higher end functionality and maybe a lot of the software functionality will come from autonomy and will trickle down. But a lot of the basic implementation of hardware and features and functionality, speeds and feeds, has to come from the ADAS market. We believe the two are tied together, which is why we don't believe you can play in one. Now, the challenge is going to be that timing of when cash flow comes. You can sell today into a mobility market, into pilots, and bring in revenue. Even if you win today in ADAS, the revenue doesn't come for 3 years. So again, in our mind, you have to play in both simultaneously.
Okay, Robert. Thank you, Blair. Robert, let's bring you in. It's not totally intuitive to me what role memory plays. So could you just give me an update as to sort of how memory and semiconductors have improved, their compute power and everything else over the last 5 years, and maybe give a hint as to where we're going in the next 5 years.
Yeah, well, the hint for the next 5 years. That's why this esteemed panel is here. But great question. So from a memory standpoint and a semiconductor standpoint, I think the biggest transformation that I could articulate relative to where the automotive industry is headed is that up until COVID, the largest trade show for automotive was not in Detroit. It's in Las Vegas. It's the Consumer Electronics Show. CES, yeah. So I don't want to be dismissive about the metal benders and the look and feel and the exterior of the vehicle, but CES is the largest trade show to understand where the automotive industry is headed, and it is all about the fact that semiconductors are really redefining what the look and feel and the experience of the vehicle. And so from a memory standpoint, one of the best kept secrets is the fact that as far as an embedded application goes, there is no larger embedded software application, or automotive is the largest embedded software application in the world. So today it's about 100 million lines of code. It's moving towards 300 million lines of code. And when you start to look at, okay, where do I need to store that code, deploy that code? It's memory. And so, yeah, as a result, I mean, we're seeing semiconductors defining the vehicle, growing at a rate that's far beyond what the actual growth of the vehicles, reflect today. And memory is playing an incredibly important role in driving that growth. Again, 100 million lines of code.
Yeah, Robert, I was just going to say, this sounds like a basic point, but of course it has massive implications because, I don't know, BMW, to pick on them. I mean, they're not a semiconductor specialist, right? I mean, we've really gone over the last, say, 7 or 8 years to customers are defining their vehicles by what goes under the hood, to the infotainment system, the way it drives. I mean, when I look at, YouTube reviews, let's say, of the new VW ID4, the criticism is not really the way that it drives per se. In fact, most of the review happens before they even actually start rolling with the wheels. It's just that the software glitches in terms of how the infotainment system works. Frank, you're probably well positioned to talk about sort of that relationship there, because you're, of course, a massive tier one supplier that consults and does all this work with these OEMs. So could you just address the complexity that goes into the car these days and what role you guys are playing there?
Yeah, first of all, let me also comment on what Robert just said. I agree on the Las Vegas thing. Yeah, so this is where you see how the automotive industry is moving towards. There's another event which is in Shanghai, China, the Shanghai Auto Show. This is crazy, and it's all about software. It is all about autonomous driving. It was amazing to see those recent developments. So I would say these are the two major events right now in the world. And what you see is you see a number of new OEMs and new players, even in the tiers, where you see people who are coming out of the software business and putting that into automotive. You see new automotive companies coming up in different areas of the world where they hire thousands of software engineers first before they hire designers and people dealing with the metal parts. So and the traditional OEMs, which I'm also dealing with every day, they see that coming. So they move into their strategy a more software focused organization. And it's not only about semiconductors, it's about high performance computers in the car. And it's not enough from my perspective, and also how we position ourselves as Continental, to make these traditional, let's say, control units bigger. You need to come from supercomputers outside the automotive and make them automotive ready. And you have to change the way you develop software for large scale systems, including artificial intelligence and accelerator chips for those kind of things, in order to tackle the data. And this is a revolution in the industry right now. And in every OEM and every tier, and even the boundaries between the traditional tier one OEM semiconductor companies are mixed now. So you see the OEMs coming more and more into functions as software, doing that, seeing that as a USP. It's not anymore what's under the hood. It's how good you can handle your algorithms. And then you see a number of the semiconductor guys coming up to more system level. So, and then the traditional tier ones moving towards more an integration of the entire technology. So it's an interesting change in the industry you see now all over the world, driven by new players. The new players will be different OEMs and also different tiers in my eyes. So this will be a disruption of the entire industry.
I think Blair wants to respond to Frank, and then let me just say,
yeah.
Oh, sorry, Naveen. I was just going to say, I've got two questions lined up from the audience. So let's go to Blair, then Naveen, and then I'll ask the two questions.
So I was just going to tie together. When you look at the people on this panel, they have one thing in common, right? When you're talking about ADAS, and it's intelligence. And you can't have intelligence if you don't have simulation, because you can't learn. You can't have intelligence if you don't have memory, so that you can store that intelligence and you can apply it. And you can't have intelligence unless you have a tier one who understands system design, so that how you use data actually drives how the car responds. I think, again, it may sound very obvious but I came from the tech industry. I was the head of strategy of a company called Sun Microsystem in the hardware business, right? And then I was head of strategy for the fourth largest software company. And then I ran a database company and then a network company. And what you found is that we started with hardware, then software became more relevant, then data and information became relevant, and then network distribution became relevant. And what you're seeing is the same trend in vertical industries like automotive, where we're getting there faster. We're taking hardware and software and data and distributing it very, very quickly. And in this case, in ADAS, we're talking about understanding the environment, distributing that information to make decisions. So I think this trend is gonna speed up. We're talking about building smart routers. We're making assets smarter. So the only what I would tie together with ADAS is about increasing performance and safety, but it's about doing that through intelligent assets. And I think that's what ties everyone on this panel together.
Naveen?
Yeah. Yeah, and I think making a statement about software in general, right? And so we work with several OEMs. We actually had our Simulation World Conference. We had about which is the largest conference that we do. And we had Peter Rawlinson, who, as you guys know, is the CEO of Lucid Motors, talk at length about how they are using software and simulation in particular. And it's no longer about specific components in the car, like whether the infotainment system or whatever else that might be. It's about how do you actually work with the broader ecosystem. That includes software vendors like us. That includes some of the large cloud companies, as an example. So because what's going on, as we all know, the number of safety critical situations that will need to be handled going forward to make cars at all levels of autonomy safer than a human driver is enormous. So if you look at, for example, just kind of some straightforward scenarios like merging into traffic on a highway, there are over like several dozen parameters to consider, right? Like the relative speeds of the vehicles, the road markings, weather conditions, time of day, etc. And this can explode easily into millions of scenarios that need to be tested and validated. And that's just one scenario of merging into traffic, right? So this is the kinds of things that OEMs and suppliers are working towards because that requires clearly a different class of software expertise, ability to actually run these massive scenarios, not just once, but all the time, essentially. So standard software regression techniques, how do you do that using cloud technologies or whatever that might be, right? So that's really what we are seeing, this relationship of the suppliers, of the large automotive companies, working with simulation, working with data collection, how do you collect data at scale so that you can figure out what's going on in the real world, etc. Right? So that's kind of the bigger software change that we are seeing.
Okay, let me get to just a couple of questions from the audience. I'm guessing this one is best placed for Frank, but anyone could jump in. Who will be first with automatic lane keeping being legalized in the UK and Germany? Is this low-speed, hands-free function the best intro to autonomous?
Yeah, that's a good question. It is, I don't know who will be first, but it's the low speed certainly brings a number of advantages to test out some technologies and then apply later on different use cases, even high speed and high-risk scenarios. So for what I see at the moment is the most promising trends in applying those kind of technologies I recently saw in Asia. To be honest, this is neither Europe nor US. This is in Asia, and it's certainly coming in different scenarios from low speed to high speed use cases. You can see nicely applied, and I saw that just recently, as I said, in the Shanghai Auto, there were some impressive ideas how to implement this and put it into a car.
The second question is clearly a Tesla question. It says, what is your perspective on marketing ADAS capability as full self-driving, in quotes? Does anyone have any particularly good answer there? Because I sort of feel like it's just universally condemned that this is clearly, conflating ADAS with full self-driving is just a bad idea. So if anyone wants to add
yeah,
to that,
listen, I mean, given that we're a supplier into that market, I think the name autopilot is the worst piece of the puzzle, right? Because I think people, to your point, conflate that with autonomy. And if you take a look at the ADAS systems today, whether it's Super Cruise or whether it's Tesla updating cameras and radar, they do some wonderful things. And in fact, people are willing to pay for those things. In Tesla's case, $7,000 to $8,000, they have a 33% uptake rate. And in Super Cruise for $3,200, maybe a 60%. I think the challenge is that in high speed on highway, there's no way you cannot have a deterministic sensor. You need a LiDAR sensor. And I would argue...
Right. Super Cruise has LiDAR, right?
Pardon?
Super Cruise has LiDAR.
It's LiDAR maps. It
okay.
uses LiDAR.
Yeah, you're right.
It doesn't use long-range LiDAR. We found this out in the military years ago. We've been doing it for 75 years. When you have high speeds and you have small objects, you need a deterministic sensor. And that's what LiDAR is. There's going to be cameras and radar forever because they're great sensors. In fact, the system itself, as Naveen alluded, will include how these sensors work together. Our big premise, and you've heard this before from me, Patrick, is that the first generation is always speeds and feeds of hardware. we're actually software oriented. So for us, when we work with people like Frank's company, Continental, we license software. Now we give hardware designs out, but hardware is going to change. The reality is all the intelligence for how you actually manipulate data is going to happen in software the same way it happens in automated targeting systems, missile defense systems, any of the more advanced systems. In fact, our rocket that's going into space has a LiDAR system. So, for me, Tesla didn't make sense for them, or Super Cruise in their first generations. I think you're going to see when we move to highway-based scenarios that you'll have more of a system approach, and you'll add in deterministic sensors, high-performance sensors like LiDARs. Because
I think you've actually said that LiDAR is going to be in virtually every car in 5 to 6 years, right? Which is, if I'm getting that right, that's an astonishing statement, because I think it must be somewhere between 0 and low single digit. Yeah, okay.
Right, but what I would say, just to be fair, because the panel is about honesty, is there's going to be some form of LiDAR in almost everything. We already have it in an iPad. We already have it in spaceships. We're going to have it in cars. Using lasers to get deterministic 3D models of depth will happen. The only question is what type of LiDAR and how quickly it will be adopted. And those two factors are what's going to make the market work. It's around business models. Now, people like Ansys are going to make a lot of money because they're always going to support new technologies and new sensors. And they're going to add in the complexity and simulation of multiple sensors working at the same time. So there is no doubt that LiDAR will be in almost everything that moves or that tracks things that moves over the next 5 to 6 years. Again, the question will be the business model that gets it there. That's why earlier when I said, why is ADAS critical to autonomy? Because ADAS is the application that will lower the cost so that autonomy can be used in different scenarios.
Right. I mean, LiDAR is even in the iPad and one of the iPhones these days.
Yes, because it wants to see depth and distance.
Sorry, I'll go to Frank, and then Robert, I've got a question from the audience for you.
Just to add on this, you say ADAS is critical to autonomy. I fully agree, because you need the mass market, you need to get down the prices, the cost, and also increasing the safety. But it's also the other way around, because you need to be active in the higher level in order to have this experience you need in fleet operation and robotaxi operation, in order to make even your level 2+, which is the current assisted driving on the road, better. Because you need to have a certain type of playground to test these higher level functions, have a fusion of several of those sensors, and then getting the best of this into the cars of today. And that's also what we are doing. We're looking in both directions. You cannot just look at ADAS only or in autonomy only. You always have to look in both markets.
Can I add something?
Okay. Robert, question from... Oh, sorry. Go ahead.
Yeah, I think I agree with Frank. I think so, and this is kind of very consistent with what we see. So when we started off working with folks like on this panel, I think there were obviously the initial set of sensors, camera, radar, etc. But even among those sensors, we are seeing a lot of work going on to essentially push them to the limits, right, from a hardware standpoint or a software standpoint. Right. And they are able to do that now because with the ability to do essentially simulations with all possible edge cases that you could possibly imagine, weather related, road related, etc. There is a lot of work going on there. Having said that, yeah, I think we do see this idea that there's going to be a multitude of sensors, both the number of sensors and the types of sensors. Yeah, and also this idea that and this is the work that, for example, I referred to earlier, we're doing with OEMs like BMW, where there is a focus from day one on the full chain, right? And the full chain might be, as Frank was referring to, how do you connect the ADAS pieces to the AV pieces? The focus at a given time might be on one part of it. But the idea is to see how do you actually connect the two things together from the beginning.
Robert, let me give you this question from the audience. What will happen to car makers that still think it's the supplier's responsibility to develop sensors, software, etc., and don't realize they are the integrator? I've got some thoughts on this, but let's start with you. Oh, you're on mute, Robert.
Let
me take myself off mute, and then you can hear all the wonderful things I have to say. Yeah, I think this is a wonderful question, because I think the problem statement is getting quite large in terms of who owns what and who's going to take a systems view of the entire problem. But at the end of the day, I think the winner in this space is going to really take a holistic view at what is required to address the bigger problem at hand. And, the transitions or the things that I'm seeing happening in my world is that we're seeing a closer collaboration with the tier ones. We're seeing a closer collaboration with the OEMs. And it's really a call out to the fact that all the different components in the system really impact what's required to be successful in this space. So, I expect to see big changes happening, and the role of the semiconductor supplier is going to change dramatically in this space.
So, Frank, maybe you can address this. I think it's sort of a massively unanswered question, what role the automaker is going to play in relationship to the supply chain over the next 10 years. I mean, Tesla has become the most valuable car maker on the planet. And pioneered a whole bunch of things, not just electrification, but OTA updates, and to some extent the autonomous capabilities. Although you might put that down to marketing, but nevertheless, they're more vertically integrated really than anyone, in part out of necessity because things like the battery supply chain really didn't exist when they got started, but now it does. And I think if you're a Volkswagen, a GM, a BMW, it's not clear to me that even if you're sort of following Tesla in the spirit of OTA updates and electrification, you're not necessarily following in how vertically integrated Tesla is, in part because you no longer need to, and in part because that's not how they've operated the last century. So how is that relationship going to change over the next 10 years? And am I right to think there's going to be a sort of vengeance of the supply chain taking on the pioneer?
Yeah, certainly. I think it will change over time. And it is rapidly changing already now. It not necessarily will end up what Tesla is doing today in the vertical integration in the full stack. What I would believe is there are certain areas all the OEMs are targeting now to have a USP, and these USPs are much more, as I said before, in software and functions where you can provide to your customers. And this could be in electrification, could be in autonomous driving, where you have something to offer which others maybe can't do right now, or just have it in a different version. So they want to have software as a new USP rather than the engine or other, let's say, exterior things. So, and as such, they will define their areas where they want to be in vertical integrated, but there also will be other areas where a sensor fusion happens, or some raw data are collected and stored or transferred. So these things could be easily transferred also to suppliers, to other, let's say, pieces in the supply chain. You don't have to do everything by yourself. But I think there will be a dramatic change of what an OEM is treating as a absolutely necessary USP. And software will be a big part of that. And I think most of our customers understood this. But there's also a number of application and functions which still would remain in the supply chain. And it depends a bit on the strategy of the single OEMs. What chunk of this the entire development chain is given out as to a system integrator, or is done within the OEM itself.
5-6 years ago, the OEM industry seemed to be sort of, terrified that the likes of Google, basically big tech, was just going to take over, right? And I remember some of my first stories in Germany in 2016 were at the Geneva Car Show when the Zetsche from Daimler was talking about the fear of being the Foxconn of the car industry. I get the sense that really hasn't played out at all, right? I mean, the sort of problem, or it hasn't been solved nearly as quickly as the tech companies thought they would, right? They sort of applied a software mindset to a hardware problem, and although they're causing disruption, it's not on the scale that they thought, right? We don't have tens of thousands of commercial robotaxis the way that was envisioned. So, Blair, maybe you could just address to what extent are we still in a Detroit versus Silicon Valley, if I'm to sort of use the parochial paradigm?
Right. Look, I still think it comes down to the macro trend, which is look, in a durable good, the hardware is really important, right? And the car industry has been able to make massive improvements in hardware performance for years and years and years, just like the aviation industry did when I was running the airline. What you're finding now is the improvements in the hardware are being driven by software, by data, and by network distribution of that data. And so, in that sense, companies were right. You take a look at who's in the car business today. Google's in the car business. Amazon's in the car business. Microsoft's in the car business. Apple's in the car business. So while it hasn't moved as quickly as you thought, just like Tesla, who is really a software company, they have a supply chain, but their real jumps have been in software. I think that both the OEMs and the tech companies are actually helping each other move through this. I can make a couple predictions, which I feel very, very comfortable in. There's going to be a lot more sensors in every car every single year. As the cost goes down for cameras and radars and LiDARs, the more sensors, the more you understand your environment. There'll be more sensors, not less. The second is that this is a system problem. A couple of people on the panel have already said that. So the sensors will need to work together, which means that it's really about software manipulating data at some level safely, which is one of the reasons we partner with tier ones who have that kind of ASIL B of D and functional safety kind of experience. And the third thing I would say, which may be a little bit controversial in my space, is that you can't have passive sensors running autonomy. You have to have an active sensor, which means that the software has to control it. Most sensors in my world today, the LiDAR world, they passively collect data and then they dump it into a software to analyze it. My prediction is that you will never have full autonomy without the software actually being situationally aware and helping the hardware be smarter. If you take a look at how humans see, which, by the way, 92% of accidents are distraction, not the capability to understand the human environment. Humans do 75% of their processing on the edge. They get 40% through orthogonal data through other senses like hearing, and they use AI to actually make intuitive jumps. So what I will tell you is if we're ever going to have vehicles be smarter than humans, you're going to have a lot of sensors with a system design, and they're going to be active so that they can actually change when it's raining and when they're on the highway or in a city. And I think that's really exciting because I think that will flow through any asset that moves or any assets that track things that move. We're going to have a renaissance in the next 5 years. The cost of things like LiDAR have already come down 90%. That's amazing in the last 5 years.
Robert, you've told me that ADAS. Oh, I'm sorry. Navin, go ahead.
Maybe one thing I could add. I think what we see happening is this fundamental change. So leaving aside the fact whether car companies are going to make cars or not, but we are definitely seeing a shift in the relationship between how OEMs and suppliers work with the tech companies, particularly the big cloud providers, right? Because and COVID maybe has a part to play in this. But I think more important, the trend is pretty secular because, as I was saying, if a big part of bringing a car to market is also about cutting how much time it takes you to get there, cloud has a very significant role to play in that. Not necessarily in the new use cases like EV or ADAS or autonomy, but even in many of the existing use cases that are still critical, but there is a desire now to actually cut down the cycle time, right? And secondly, as cars getting more connected, you need to do data collection and do that at scale, run AI algorithms on top of that. These are areas that some of the big cloud providers already have the best expertise and will continue to have that, right? So this getting together of the hardware supplier with the hardware ecosystem is much tighter than what it was maybe just even a few years ago.
All right, Robert, I'm going to give you just 30 seconds for the final round here. You've told me that ADAS has really become the decisive factor for some car buyers, right? Sort of infotainment and ADAS. So, what's going to happen in the next 5 years as the industry, so long as if they realize that and they have to prioritize that, how much better are these systems getting in the next half decade?
Wow. How do I answer that in 30 questions or 30 seconds? But, at the end of the day, I mean, people are choosing their vehicle or making their purchasing decision based upon ADAS capabilities, in-vehicle infotainment. This is becoming a big component of the brand identity. And increasingly, semiconductors are going to play a bigger role in, really defining the vehicle. And I think, I don't think there's anybody on this panel that would disagree with me. I think everybody's going to say, yeah, it's not bending metal anymore. It's the experience that semiconductors bring to the table, whether it's increased safety or in-vehicle infotainment experience, apps that you can run in your vehicle. There's a whole litany, but it's not metal. It's silicon. Today, it's going to be silicon. Yeah. And
well, it's things outside the control of the very brand that you go to purchase from. So sort of hidden from the consumer, which is fascinating. All right, I'm afraid we're out of time. So Blair, Naveen, Frank, and Robert, thank you so much for a fascinating discussion. Next up, we have Dr. Rianne Mary Thomas. She is the CEO of the Green Finance Institute, which is backed by the UK government and the City of London Corporation. She's formerly the head of global green banking at Barclays, and she's going to give us, I think, a 15-minute discussion. I'll facilitate a little Q&A after that. And I know for some people over here, we're also going to have breakfast. So thanks so much, guys. Really appreciate the discussion.
Thank you, Patrick.
Thanks, Patrick.